Okay, so if we're talking about global wind circulation patterns, we're talking about the dominant force that drives the overall predominant winds at a given latitude, based on a few different factors. Okay, so I think there's like 4 keys that you'd want to know to remember the whole thing. So my first question there, so we've already determined that air rises in zones of something pressure. Think about it for a sec. Okay, hopefully you got that was low pressure. Okay, so then this creates a void, right? It's almost like a vacuum effect. This creates a void causing winds to blow into it from areas of obviously high pressure. So this happens on a local scale. This happens on a global scale as well. So my next key, so there's your first 2 keys. The air rises at zones of low pressure and wind blows from zones of high pressure. My next 2 keys then, because of the rotation of the Earth, winds in the northern hemisphere are deflected to the, you got to take a guess at this one. It's either right or left, you pick. Okay, hopefully you guessed right. Does it matter? Not at all. But in the northern hemisphere, winds are deflected to the right. Okay, while in the southern hemisphere, winds are deflected to the, you got it, deflected to the left. Okay, this is caused by the, something you might not know. So this is caused by the Coriolis effect. Sorry, I kind of wrote that small. It's C-O-R-I-O-L-I-S effect. And so what that is basically the spin of the Earth, causes a bit of a deflection one way or the other, depending on being above or below the equator. I'll show you an example of that in 1 second. Okay. So now I've got a box of key terms here at the bottom, right? And so my key terms, I think we can, by process of elimination, plot out a few of them really quick. Obviously, the bottom left corner here, equatorial low, would likely go right around the equator. So if I were you, I'd write it across the line. Equatorial low. And so if that's the equatorial low, obviously then we can check that off. We got a few more that we can do right away. Polar high. Now the Earth's a mirror image, top and bottom obviously here, right? So we have polar high there. And then we obviously have polar high there. And again, I'm trying to write them like through the line, let's say, and through the line and through the line, right? Okay, so now we got ones that are just above the tropics and just above the poles, or just above or below the poles, right? So I think it's pretty obvious then that you'd have the subpolar low would be just below the poles, right? Subpolar low, and then subpolar low, right? And so that then obviously leaves only the subtropical high right there. Okay, now I know just based on process of elimination you could have done that yourself, but I think it should kind of make sense when you look at it. You have the equatorial low in the middle. Why is it a low? For right now it's just a low. It's the equator, so we're going to put an equator. Polar high because it's in the poles. Subpolar low just because it's just below the poles. And the subtropical high, well, by this point you only have one place to put it, and it's in the tropical regions, tropics being about 23.5 degrees north and south of the equator, and these are about 30. So the first thing I want you to do here then, let's check these off first, okay, 1 and 2, sure. So step 1, done. Step 2, done. Cool. Okay, so you want to visualize this whole thing as a 3-dimensional shape, right? So it's a sphere, just like the Earth, let's say, right? So it comes off the surface there, and it goes below the surface, right? And so it's a sphere. So picture a 3-dimensional shape everywhere here, right? Okay. So if I were to draw an arrow like that, that's not going west, that's rising off the surface of the Earth. The same that I could draw the arrow that way, or I could draw the arrow straight towards you, or I could draw the arrow straight away from you. It's a 3-dimensional sphere, right? So let's picture this as not west, but this is simply air rising. Now take a guess. Why do you think air rises at zones of low pressure? Why do you think there's a zone of low pressure around the equator? Okay, so I hope you guessed that it's because of the amount of insolation that they receive. There's winds that converge at the equator, but it's largely driven by the fact that you have the most direct overhead sunlight or insolation hitting in the tropical or equatorial region, which would then give you the most volatile warm air, most likely to rise. Cool. So we said that air rises in zones of low pressure and wind blows from zones of high pressure. So if we have a high and a high, this rising effect at the equator is going to force winds to blow in from the subtropical regions. It rises at high, it blows in from low. That's it. So if it rises at high and blows in from low, once it rises, air when it rises, it hopefully you said cools, condenses, and falls. So as air rises, it cools, condenses, and falls. So this creates almost like, it's called a Hadley cell, but I don't care if you remember that. It just creates a cycle, almost like convection currents rising in the mantle. It's all driven by convection all over again. We have an equatorial low. Why do we have an equatorial low? Because it receives the most direct overhead sunlight. When you receive the most direct overhead sunlight, you create the warmest, most volatile air. Volatile air likes to rise. When volatile air rises, it cools, condenses, and falls. And when the air rises here, it creates a vacuum effect from the two tropics, blowing air in to replace it. Cool. So we don't need to do this, but this happens that way, and that way, and that way, and that way. And it also happens at the polar regions as well. So the polar regions as well, the subpolar regions, subpolar low, is an artificial zone of low pressure caused by the collisions of air masses. So in theory, you could draw the exact same low and low and low and low, but we're not going to do that because this isn't the most important thing in the world to me. So now, if air rises at zones of low pressure, wind blows from zones of high pressure. So in this little chart here, in this diagram, sorry, you should have an arrow going from every high to every low. So every high to every low. So I'm going to do this, give you a second to look at it and see if it makes sense. Okay, so all I did was I drew an arrow. As I know already that wind blows from high to low, I drew an arrow from every high to every low. Now we got to factor in this thing. Okay, so because of the spin of the Earth, it causes these arrows to deflect a little bit. It's as if you were throwing a frisbee. Because of the rotation of the frisbee, sometimes you have to aim it a little bit to the right or to the left, however you're throwing, in order to get it to a person because it'll naturally tail. I don't know if yours does, but mine does. I can't get it to go straight. So because it naturally tails, I have to angle it off a little bit. Let me see if I can come up with a bit of a visual here. One sec. So if I look at my absolutely terrible globe that is missing pieces and all the rest, I don't know what people do to this. I'll move this out of the way really quick. So if I go to my globe here, so there's not too many sections that are still accurate, but okay. So if I start here and I just draw a straight line down to the equator, I would end up, let's say, going from northern Canada, I would end up somewhere in Venezuela or Colombia. However, because the Earth is spinning at the same time, if I was to continue to draw my straight line, I end up somewhere in this, somewhere in the Pacific Ocean, just past that black square of death. Cool? Now, if I go the other way, same idea. If I start in Venezuela or Colombia, I should, in theory, end up in northern Canada, northern Quebec, right? So, because the Earth is spinning, instead of ending up in northern Canada, all I'm doing is drawing my straight line. I actually end up, let's say, Alaska or the Gulf of Alaska, somewhere like that. So that's just a visual of the spin of the Earth causing those winds to deflect. So now the up arrows are easy. Remember that, the up arrows are easy. The up arrows are easy. So let's do this one here first. So this goes from high to low, as we said already, because air is rising at low and wind's blowing from high. So we have high to low. When it goes from high to low, it's going to break to the right. It's right, not your right. That's a key. It's going to break to the right because it's in the northern hemisphere. So it's going to break to the right. I'll leave that for a second. The wind's going to break to the right because it's in the northern hemisphere. So all I did was wind is blowing from high to low, breaking to the right because it's in the northern hemisphere. So we can get rid of some easy ones as well then here. This is below the equator, obviously. So if it's below the equator, winds are going to break to the left, all caused by the spin of the Earth. So the up arrows, I'm going to tell you, are your easiest ones. So we should be able to see that. So while the wind is just simply going from high to low and following this pattern right here, as it goes from high to low, it has to spin because of the Coriolis effect that the spin of the Earth puts on the wind, the deflection that it puts on it. So as it puts that deflection, the up arrows are easy because these are going to the left, and to the right, just simply because you're memorizing above the line right, below the line left. The only problem comes in the down arrows. So I'm going to draw them quick and then I'll leave you a second to get upset and hate them, and well, we'll go from there. And this would be... Okay, so what the heck did I just do there? Okay, so the up arrows are easy. This went up and turned left. This went up and turned left. This went up and turned right, simply because it's above or below the equator. Now this is also turning to the right because it's above the equator. However, I get it. It looks like it's going left. This also is above the equator, so should be turning to the right, but I get it. It's going left. This is below the equator, so I get it. It should be going to the left. However, it goes to the right. It's simply the fact that it goes to its left and it goes to its right and its right. It might be your left, but it's its right or left. Okay, so quick visual here. If you pictured yourself in a car, I'm not a great artist, so if you pictured yourself in a car, there are your headlights, okay? So if you're in a car and you want to make that turn, well, think about it. It's going to your left. However, it's actually a right turn. Your left, actually a right turn. So the same idea is going on here. So, sorry. Okay, so if that is actually going to your left, if I were to hold this section and flip it upside down, it's actually a right turn. It's just simply going to the left. If you need to cheat a little and flip the piece of paper upside down, I totally get it until you grasp it. Okay, so what we have here, we produced, again, all we're doing is air rises at low, blows from high, spins to the right in the northern hemisphere, spins to the left in the southern hemisphere, all caused by the Coriolis effect. We just took those four basic principles and plotted them all on this using a little bit of common sense and, well, some logic. But so what this causes is there are predominant wind patterns throughout the world. If you're in this region, you should have a predominant wind pattern that way, or your weather should blow a certain way, or you should be influenced by air masses coming from a certain way, that type of thing. Just the same as here, 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 here. Okay, so in the bottom right corner, last thing, what the heck are they called? Okay, so we can get rid of some easy ones here. The polar easterlies. Okay, so the polar easterlies are obviously in the polar to subpolar region. Polar easterlies, okay, and polar easterlies. Okay, so that's easy. I get it. This one's actually coming from, let's say, the southeast, and this one's actually coming from the northeast, but they're predominantly the polar easterlies. Just the same as here, we have the westerlies. Again, coming from the southwest. That's why, if we live in this region, this is why we have our predominantly southwesterly wind pattern. So then we can do the same here, where this is from the west, more specifically the northwest, but the west, the westerlies. And then in the middle here, we have the trades. Okay? So a couple of reasons for the trade winds. You can probably guess a couple of them. Okay, so the trade winds are obviously used for trade. And then also, I like to think of it as they're trading winds. They're colliding in this intertropical convergence zone, it's known as, or this this low pressure, high volatility zone right around the equator. So let's say they're trading wind from the northern hemisphere to the southern hemisphere. It's not exactly accurate, but we'll take it. So I think from here you should be able to grasp where the regions go. If you don't remember, there's a lovely game when you were a little kid, high, low, piccolo. So high, low, high, low, high, low, high. But it's pretty easy to do it as well with the equatorials, the poles, the subpolars, and the subtropicals, right? You have your winds blowing from high to low, and deflecting to the right or the left based on the Coriolis effect of the Earth, and then you're just simply plotting. So who cares about all this? Well, we do. And why do we care about it? Because this causes the predominant interaction, the predominant winds, which causes the interaction of various air masses in our kind of local area. Okay.